So hello again, we're back doing further trigonometry. We'll just carry on from last time with a more complicated trigonometry function that we might need to solve for. So ignore that, that's the answer, pretend that's not there. So if we've got cos of 3x over 4 equals 1 over root 2 in the range of 0 and 2 pi for x, and we'll do this one in radians instead. So what we want to do is we want to draw out our graph of where 1 over root 2 pi is, and then see where it intersects. It's between 0 and 2 pi, and that means we have, if we do cos to the minus 1 of 1 over root 2, then we have 3x over 4 equals these values here, pi over 4 and 7 pi over 4. So you're just treating this as an individual thing and doing cos to the minus 1 of 1 over root 2 to get what this thing is equivalent to. And then what you just do is you solve that for x. So times by 4 and divide by 3. And that gets you the two answers that you saw immediately from the start. So what you want to do whenever you're doing a complicated trigonometry question is treat the part in the brackets here as some single quantity, so maybe change it for a or something instead. And then once you've found out what a is, then say a equals 3x over 4, and then solve it like you would any other equation. So solving trigonometry for x plus or minus n, so where it's been shifted like that. So what you want to do is solve just for x first. So I'm not going to go through an example, just going to go through the method. So you want to just solve for x first, and once you've got your solutions, then do the reverse operation. So if you've got x minus pi over 2 like it does here, then and once you've found out what x is, then just add on pi over 2 to each of the values of x. And just make sure to check that there are no solutions outside of the given range. So if you've done between pi over 2, if you've done between pi and minus pi, then you might want to just extend that a little bit further to 2 pi and minus 2 pi. So just so you know that when you do the reverse operation for all the solutions, you don't miss out any other values. So we'll start looking at what happens when we do powers with trig. So if we've got sine squared x equals a quarter, then we just do sine x equals plus or minus a half, and then we solve each of them things individually. And you can solve them by just subbing in sine to the minus 1 of a half and sine to the minus 1 of minus a half. And that gets all these values if we're doing it in degrees. It's important as well on your calculator to keep checking whether you're in radians or degrees, because many people will make that mistake in the exam. Just make sure it's not you. So if we have our trigonometry as a quadratic like this instead, then what you want to do is factorize it as you would a normal quadratic. Treat cos x as something like a, and then you'd have 2a squared minus a equals 0, and you'd know straightforward how to solve that. So just treat the cos x as its own individual quantity. Then once you've got that, when it's equal to 0, you know 2 cos x minus 1 equals 0, cos x equals 0, so cos x equals a half or cos x equals 0, and you can find them solutions. If you've got some constant times sine equals a constant times cos, then what you want to do is you want to divide by cos on both sides. So you've got, and divide by the sine constant. So then you've got tan theta equals 4 over 3. And then you solve that for tan, using tan to the minus 1. And make sure you get the second angle as well. So there's a lot of methods in there. You might want to go back through that slowly and have a good proper look at it, but just keep practicing with trigonometry, know the methods for the quadratics, for the multiple sines and cos, and all the other things. Let me know if you've got any questions.